What is a fragment of another world doing here, drifting into the dominion of our sun? It does not blaze like a comet in full glory. It does not follow the neat clockwork paths that astronomers have charted for centuries. Instead, it arrives like an intruder at the edge of a cathedral, silent and unannounced, carrying the weight of a history that no telescope can fully decode. Telescopes across the Earth turn toward it. Sensitive detectors, vast mirrors, and restless algorithms trace its position with precision. Yet the sharper the view becomes, the less it resembles what the models predict. It does not behave like the frozen remnants of our own solar system. It does not drift like the asteroids that orbit between Mars and Jupiter. It slips between categories, eluding labels as if carved by laws of nature that were never written here. A messenger from another sun, a shard of alien geology, a body shaped in silence traveling through the black sea of interstellar space, carrying no flag, no intention, only its existence. But existence here is enough to raise questions that cut to the marrow of human curiosity. Why does every new observation deepen uncertainty instead of dissolving it? Why does the act of looking more closely only blur the outline of truth? Astronomy, a science built on clarity, finds itself here wrestling with paradox. A visitor that should reveal answers has instead become an oracle of riddles, whispering of forces, collisions, and histories older than Earth itself. And so the mystery stands. A fragment not of us yet among us, its silence louder than any signal, its trajectory a question written across the stars. On the night of April 12, 2020, a faint point of light appeared in the skies above Hawaii. The signal was captured not by chance but by a survey designed to guard our planet. The Atlas Project, an automated system of telescopes built to detect hazardous asteroids, registered the object as just another moving dot among countless stars. Its designation was clinical at first, C2020 M3, a label for yet another comet in the solar system's endless traffic. But the more carefully astronomers traced its motion, the more unsettling its story became. This was no ordinary comet. The Atlas telescopes had inherited the task of searching for near-Earth objects, instruments stationed on the volcanic slopes of Haleakala and Mauna Loa, scanning the heavens with unblinking regularity. Pan-STARRS, their sibling survey system, soon joined the watch, mapping the newcomer's trajectory with precision. Within days, data began to converge. Its speed was too great. Its orbit did not close around the sun. The numbers revealed what the eye could not. This object was not bound to our star. It was interstellar. Only once before had humanity encountered such a messenger. In 2017, the discovery of 1I Oumuamua had shaken the foundations of planetary science. Then, in 2019, the comet 2I Borisov confirmed that interstellar travelers were not impossible rarities, but real visitors from beyond. And now in 2020, a third appeared. It was named 3I Atlas, marking it as the third recognized interstellar object in recorded history. The scientific community stirred with a mixture of awe and determination. To catch such a visitor is to peer into another star's workshop. Here was a fragment of matter sculpted in the furnaces of an alien system, shaped by a history untouchable to earthly geology. At last, astronomers thought, this one would provide clarity where its predecessors left only questions. Observatories around the world turned their lenses toward it. Optical surveys from Hawaii, Chile, and the Canary Islands. Infrared readings from NASA's NEOWISE spacecraft. Radio observations tracing its outgassing. Searching for chemical fingerprints. Each dataset promised a revelation, a glimpse into the chemistry and structure of a world that formed under a different sun. But expectations carry their own weight. In the quiet anticipation of scientists, there was a belief that 3I Atlas might finally yield answers to the riddle of interstellar debris. Was it a comet, rich in volatiles, carrying frozen clues from a distant nebula? Would its dust reveal isotopes foreign to our solar history? Could its orbit whisper the architecture of the star system it came from? For a brief moment, the narrative seemed simple. Humanity had been given another chance. A second messenger after Borisov, a third after Oumuamua, a chain of witnesses to the larger cosmos, each carrying stories across the gulfs of interstellar space. Yet even in its discovery, there lingered the faintest trace of paradox. Every line of data promised clarity, but already subtle irregularities hid within the noise. The excitement of finding a new interstellar traveler carried with it a shadow. as if this fragment, like its predecessors, had come not to answer questions but to deepen them. The first weeks after discovery carried a sense of exhilaration. Astronomers across the globe collected fresh measurements, each telescope tracing the faint glow of 3I Atlas as it drifted deeper into the solar system. Its orbit was mapped with care, every data point tightening the lines of prediction. Yet the calculation soon bent against expectation. Instead of following the graceful arcs familiar to comets and asteroids, the trajectory refused to obey. Its path through the solar system appeared skewed, its momentum untouched by the sun's gravity in ways no model could easily explain. For centuries, celestial mechanics has been the most reliable language of the heavens. Newton's laws, refined by Einstein's relativity, leave little room for surprise. Planets, asteroids, comets, all follow the mathematics with exquisite loyalty. Yet here was an object that drifted outside that order. When scientists projected its course backward through time, it did not spiral inward from the frozen reservoirs beyond Neptune. It came from infinity, arriving unbound, its orbit hyperbolic, destined to leave again for the void. But even within that narrative of interstellar passage, something was off. The numbers showed subtle deviations as though a hidden hand were pressing upon it. The brightness added another layer of disquiet. Most comets brighten in predictable patterns, their surfaces warming, releasing jets of vapor, scattering sunlight through plumes of dust. Atlas did not shine so consistently. Its light curve rose and fell irregularly, as though pieces of its surface fractured, exposing raw ice for brief moments before darkening once again. The flickering pattern seemed chaotic, defying the neat progression astronomers anticipated. Some suggested fragments were peeling away, others proposed sudden outbursts of gas, but the data resisted a single explanation. To account for the strange trajectory, scientists turned to the idea of non-gravitational forces. The thought was not without precedent. Comets are known to shift subtly when their jets push against them, a cosmic recoil from vaporized ice. Perhaps 3I Atlas too was being nudged by invisible streams, but the magnitude and rhythm of the deviation were difficult to reconcile with simple cometary activity. Its behavior whispered of something unaccounted for, something not easily folded into existing models. The déjà vu was unmistakable. Only 3 years earlier, Oumuamua had entered the solar system with the same defiant strangeness. It too refused to follow the path gravity demanded. It too displayed a light curve that shifted with unnerving inconsistency, and in its wake, controversy had spread across the scientific community, with explanations ranging from shredded cometary fragments to sails of alien engineering. Now, as 3I Atlas revealed its irregularities, the echoes of that earlier mystery stirred once again. What unsettled researchers most was not simply the anomalies themselves, but the growing pattern. If a single object defied explanation, it could be written off as rare chance. But 3 in succession, Oumuamua, Borisov, and now Atlas, hinted at a deeper principle. Perhaps interstellar visitors are shaped by conditions fundamentally different from our expectations. Perhaps the physics governing their journeys is marked by histories our solar system has never known. The instruments kept watching. Observatories fed streams of numbers into simulations, refining their models with each passing night. But clarity remained distant. The more the measurements narrowed, the more uncertainty expanded. It was as if interstellar objects arrived not merely as bodies of rock and ice, but as puzzles written into their very existence. To astronomers, the sense was unmistakable. The cosmos was sending visitors, but not answers. Each interstellar traveler entered our skies as a teacher, whose lessons began in riddles. And the question lingered like a shadow. Why do these messengers, crossing the vast silence between stars, refuse to play by rules so carefully drawn from centuries of study? When the first irregularities in 3I Atlas became undeniable, the world's observatories locked onto it with renewed intensity. The faint glow that had once seemed like just another comet became the center of an international effort, a fragile signal upon which astronomers placed their highest instruments. From Hawaii to the Canary Islands, from the deserts of Chile to the mountaintops of Europe, telescopes turned, measuring not just its path but the colors of its light. Every wavelength became a clue, a fragment of a story written into the spectrum of a body older than Earth itself. Spectral analysis has long been the key to unlocking cosmic composition. By spreading a comet's light into a band of colors, astronomers can read the fingerprints of molecules, the faint imprints of water vapor, carbon monoxide, carbon dioxide, cyanide. It is the closest thing to touch across the void. And yet when 3I Atlas was examined, the signals were faint, uncertain, and often contradictory. Some data hinted at water ice sublimating under solar heat, whispering of a structure similar to the comets that haunt our own Kuiper belt. Other data sets were inconclusive, too thin to confirm. Where Borisov had blazed with clear cometary chemistry, Atlas seemed reluctant to speak. Its voice was soft, its message fractured, as if it had been worn thin by eons of interstellar exposure. Teams searched for a tail, that classical signature of a comet's life. Photographs showed faint diffuse emission, but it shifted unpredictably. Sometimes the object looked like a fractured nucleus breaking apart, sometimes like a comet in retreat, its gases too weak to sustain a steady plume. As the sun's light warmed it, astronomers waited for the familiar surge of activity that marks a comet's closest approach. But Atlas remained subdued, flickering in ways that resisted prediction. Its dust, if present, was meager, its jets too inconsistent to account for the strange accelerations recorded in its orbit. Models were built to reconcile these mismatches. If water ice was driving sublimation, then its acceleration should follow a calculable curve. If carbon monoxide dominated, the pressure of escaping gas should have been stronger, more measurable. But the numbers refused alignment. The deviations were real, the trajectory bent by some invisible influence, but no single mechanism fit the data cleanly. Every attempt at precision fractured into ambiguity. Each refinement only exposed new gaps in understanding. This paradox deepened with time. The closer scientists looked, the less coherent the picture became. High-resolution imaging revealed fluctuations in brightness that could not be matched to rotation alone. Spectra showed fleeting signatures of volatiles that vanished on reobservation, as though the object were speaking in half-truths, revealing only fragments of itself before closing again. Dust measurements suggested mass loss, but too little to explain its defiant motion. At moments, Atlas seemed to behave like a comet that had nearly exhausted its volatiles, a remnant stripped bare by ages in the deep cold between stars. At other times, its accelerations hinted at hidden reserves, a reservoir of forces waiting beneath a fragile crust. For scientists, the investigation felt like walking through a hall of mirrors. Every question split into two more, every calculation bent against the evidence. If Atlas was a comet, it was unlike the comets known to the solar system. If it was a fragment, its story was hidden under scars too ancient to read. No conclusion felt final, only provisional, suspended in the widening space between theory and observation. And so the paradox grew. An object crossing into human vision for only a brief window, yet refusing to deliver clarity. The universe had offered up a shard of alien history, but its language remained broken. What was expected to be an answer had become a riddle, a cosmic puzzle that only deepened with every step toward resolution. The deeper astronomers pressed into the study of 3I Atlas, the more the mystery thickened around it. It arrived as a comet, yet did not behave like one. It displayed traits of an asteroid, yet could not be confined to that category either. What was thought to be a simple classification exercise became a confrontation with uncertainty, as though the object itself refused to be named. Early brightness estimates suggested a nucleus several hundred meters across, modest compared to many long-period comets. But as the data accumulated, the figures diverged. Some models hinted at a body closer to a kilometer in size, while others implied a nucleus that had already fragmented, scattering dust and debris into a faint, uneven coma. The light curve did not rise and fall with the steady rhythm of rotation, but with irregular flickers as though its surface was fractured, jagged, and unstable. No telescope could pin its shape with certainty. It seemed less like a whole traveler and more like a survivor, the remnant of something larger that had already been broken by the violence of interstellar space. Signs of fragmentation grew harder to ignore. Some observations captured transient brightening events, sudden surges in luminosity that suggested fresh pieces breaking free. Dust clouds appeared and then dispersed, leaving the nucleus dimmer than before. It was as though the object were disassembling before the world's eyes, an ancient relic unspooling into silence under the pressure of solar heat. The question arose, was this the moment of its disintegration, or had it already arrived shattered, a splinter torn from a greater parent long before it crossed into the solar system? Speculation began to spread. Perhaps 3I Atlas was not a singular body at all, but a fragment, a shard ejected from a catastrophic collision in a distant planetary system. Perhaps entire families of such fragments wander between the stars, invisible until they chance upon the light of another sun. Some theorize that the galaxy might be filled with this debris, the broken remains of comets, asteroids, and planets destroyed in ancient upheavals. If so, then interstellar visitors may not be rare intruders, but a quiet, steady rain of fragments, most too faint to detect, slipping unnoticed across the boundaries of our skies. The implications were haunting. If 3I Atlas was only a fragment, then how many others drift unseen in the dark? How many pass through the solar system each year, their trails too faint for current instruments to catch? And what larger parent might have given birth to this shard? What distant star system, what violent event, what history lost to time? Each observation drew scientists closer to the unsettling realization that classification itself might be a human illusion. Nature did not design clean categories of comet or asteroid, solid or shattered. Instead, it delivered a body that blurred lines carrying both ice and rock, both order and fracture. The cosmos seemed to be reminding humanity that its vocabulary was insufficient, its definitions too narrow for the vastness beyond. As 3 Atlas unraveled, astronomers watched with a mixture of awe and resignation. What they hoped would deliver answers had instead revealed a deeper abyss of questions. The more they measured, the more the object receded into ambiguity, a reminder that the universe does not owe clarity to its observers. The haunting possibility lingered in the silence between data points. Perhaps such visitors are not exceptions but the rule. Perhaps the galaxy is alive with them, shards of forgotten worlds endlessly crossing the gulfs between stars. Perhaps humanity is only now learning to notice them, one faint messenger at a time. And if that is true, then 3I Atlas was not just a mystery. It was a signpost, a quiet announcement from the deep cosmos that our solar system is not isolated, and that fragments of alien histories have always been passing among us, waiting for the moment we were able to see. The longer 3I Atlas lingered in human observation, the more it seemed to resist containment within the familiar boundaries of science. Data continued to accumulate, spectra, light curves, orbital models, yet none of it fit comfortably within the expectations that guided planetary science for centuries. And so, as has always happened when evidence defies structure, the human mind turned to theory. Speculation became the necessary bridge across the gaps, each hypothesis a scaffold built against the vastness of the unknown. One school of thought held that Atlas was an exotic comet, carrying unfamiliar ices forged in conditions unlike those of the solar system. Its erratic outgassing might have been driven by molecules rare or unstable in Earth's environment, carbon monoxide, carbon dioxide, or even nitrogen-rich volatiles preserved for billions of years in the coldness of interstellar night. As the sun's heat penetrated its fractured crust, these alien ices may have sublimated unpredictably, releasing jets too irregular to model with the tidy curves used for ordinary comets. If true, Atlas would not only be a comet, but a messenger of chemical diversity, a frozen relic of processes invisible to human laboratories. Another theory pushed further into the violence of cosmic history. Perhaps Atlas was once part of a larger planetesimal, a building block of planets in a star system long forgotten. If so, it may have been torn apart in a cataclysmic encounter, tidally disrupted by a massive planet, or shattered by collision with another body in its home system. The fragment that entered our skies would then be only a shard of that destruction, carrying scars of tidal stress and fragmentation that shaped its irregular surface and unpredictable behavior. Such a history would not make it unique but typical, for planetary systems across the galaxy are sculpted as much by ruin as by creation. Still others suggested a more subtle transformation. The object, they argued, may have been altered not by collision but by time itself. Drifting for millions of years between stars, its surface would have been bombarded by cosmic rays, its chemistry gradually rewritten by the high-energy particles that permeate interstellar space. Layer by layer, its original identity would have been eroded, leaving behind a body that only faintly resembled what it once was. Each pass near another star could have reshaped its orbit, stretched and deflected by gravity, until it finally wandered into the sun's domain. In this view, Atlas was not only a fragment of another world, but a palimpsest, a text erased and rewritten by the galaxy itself. Comparisons to earlier visitors were inevitable. Oumuamua, elongated and enigmatic, had been imagined as a cigar-shaped rock, tumbling through sunlight with inexplicable acceleration. 2I Borisov, by contrast, had behaved more like a conventional comet, its activity clear, its structure recognizable. Now Atlas presented a third profile, neither rock nor comet, but something fractured, unstable, and chaotic. It seemed to suggest that interstellar objects do not arrive in a single form, but in a spectrum of possibilities, each one reflecting the variety of origins scattered across the stars. The galaxy was not sending humanity the same message twice. Each visitor was a different dialect of the same deeper language. Inevitably, speculation reached its most daring frontiers. Could such objects be relics not just of alien chemistry, but of alien systems entire? Might they carry within their structures the fingerprints of worlds that once orbited stars now dimmed or extinguished? Each fragment could be a survivor of planetary creation or planetary death, an emissary of histories never witnessed by Earth. Some scientists even dared to ask if these travelers might carry more than geology. If worlds beyond gave rise to life, might their shattered pieces bear traces, organic molecules, frozen chemistry, that hint at biology unimagined by terrestrial science? The question hovered, unanswerable yet inescapable. Are we glimpsing only stones or the ruins of alien gardens? With each theory came an undercurrent of philosophical discomfort. Science thrives on classification, on the power to name and order. Comets, asteroids, meteoroids, each has its place, each defined by boundaries and laws. Yet here was an object that slipped between definitions, dissolving categories as quickly as they were applied. Atlas forced astronomy into a posture of humility, demanding speculation not as indulgence but as necessity. Its very resistance to naming became a message, a reminder that human systems of thought are provisional, fragile, and incomplete. The theories multiplied, but certainty remained elusive. Whether exotic comet, fractured shard, or rewritten relic, 3I Atlas existed in the liminal space between understanding and mystery. It was a body, yes, but also a mirror, reflecting the limitations of human knowledge back at those who observed it. And in its silence, it seemed to whisper a truth that science has always known but seldom faces directly. The universe is under no obligation to make itself simple. The discovery of 3I Atlas did not arrive in isolation. It became part of a growing realization that the cosmos is not static, and that the solar system is not sealed from the tides of the galaxy. Its fleeting presence deepened a sense of urgency among astronomers. If interstellar visitors can appear with such frequency, then humanity must be prepared not only to watch them, but to meet them. The first line of defense remains the network of wide-field telescopes that survey the skies each night. Pan-STARRS in Hawaii, the Atlas system itself, the Catalina Sky Survey in Arizona, all are designed to detect near-Earth objects, yet their vigilance also makes them accidental sentinels of the interstellar. They record faint smears of motion against the background of stars, filing detections into global databases where software hunts for anomalies. It was in such quiet labor that Atlas revealed itself, not through a dramatic blaze, but through a subtle difference in motion that betrayed its alien origin. Soon, the Vera C. Rubin Observatory will join this watch. Built on Cerro Pachon in Chile, its 8-meter mirror and immense camera will scan the entire visible sky every few nights, generating a living map of celestial change. Where older surveys catch fragments, Rubin will provide continuity. It will see the faintest intruders months or years before smaller instruments can recognize them. With such eyes, the odds of missing another Oumuamua or another Atlas will dwindle, though the mysteries they carry may only grow. Beyond detection lies the challenge of study. Spectroscopy, the art of splitting light into elemental codes, remains the most powerful tool to probe composition. From a distance of millions of kilometers, astronomers can detect the chemical breath of a body, the faint exhalations of gases and dust. Orbital mechanics, too, becomes a form of truth-telling, tracing deviations that betray hidden forces. Increasingly, These analyses are guided by artificial intelligence, algorithms trained to sift through torrents of sky data, isolating signals that would otherwise vanish into noise. Machines now partner with human intuition, each learning from the other in a race to recognize visitors before they depart again for the stars. Yet even with these advances, frustration persists. Astronomers can measure trajectories with exquisite precision, but they cannot resolve surfaces across interstellar distances. They can detect faint spectral lines, but only if the object is bright enough, active enough, cooperative enough to speak in chemistry. 3i Atlas, like Oumuamua before it, reminded the scientific world of what remains beyond reach. No matter how sharp the telescope, certain truths dissolve into silence at cosmic scales. There is only so much that light can tell when it has traveled across the void. And so, new voices have begun to argue for a bolder step, not merely to watch these objects from afar, but to chase them. Proposals have circulated for rapid response missions, spacecraft designed to wait in readiness and launch at the first detection of an interstellar body. If humanity can intercept one, if instruments can fly alongside it, then spectra can be replaced with samples, models with measurements. The European Space Agency has studied such concepts. NASA's Interstellar Probe Team has modeled trajectories, imagining spacecraft that could rendezvous with a visitor as it sweeps through the solar system. What was once the realm of speculation is now entering design studies because the urgency grows with each arrival. Atlas has intensified that urgency. Its contradictions have made clear that distant observation alone may never suffice. If the galaxy is indeed scattering fragments across our skies, then the chance to intercept one is not only possible, but inevitable. The challenge lies in readiness. These visitors move fast and they stay within reach for only brief windows of time. A mission must be prepared long before detection, a sentinel spacecraft able to ignite engines at a moment's notice. Physicists and astronomers hope to prove much. The chemistry of alien systems, the architecture of their planetary debris, perhaps even the frequency of planet formation across the galaxy. But they also recognize what cannot be proven from Earth. Without direct encounter, without a probe touching the dust of a visitor, the story will remain incomplete. Atlas has underscored that truth with its refusal to yield clarity, a cosmic reminder that distance is both the astronomer's ally and their greatest limitation. In its brief transit, 3i Atlas became more than a mystery. It became a signal of urgency, a prompt to prepare for the next, and somewhere in the future, perhaps in the lifespan of the next observatory, perhaps in the plans already drawn in quiet laboratories, humanity may not only watch a fragment from another sun, but reach it. The era of distant observation may one day give way to pursuit, and the moment of first contact with interstellar matter may finally arrive. 3 times in only a handful of years, the universe has sent messengers from beyond the boundary of the sun's rule. Oumuamua in 2017, Borisov in 2019, and Atlas in 2020. For most of human history, such encounters were unimaginable, the stuff of speculation and myth. Yet in the span of a single decade, the silence between stars has been breached again and again. Coincidence seems too fragile a word, and yet science cannot declare a pattern without proof. Still, the sense lingers that something larger is unfolding, a quiet revelation that the galaxy is more porous than once believed. Each arrival has carried its own symbolism, a shard of alien geology here, a trail of cometary gases there, a fractured body unraveling under solar heat. They are fragments of alien systems drifting into our skies like forgotten letters, slipped across the threshold of light years, written in alphabets humanity cannot yet decipher. They bring no voice, no intention, no announcement, only their presence, only their silence, and the questions that unfold in its wake. What they reveal is not only their own mystery, but the limits of knowledge itself. Astronomy is a science built on distance, on the faith that light is enough to decode reality. But here, the closer telescopes pressed, the more certainty dissolved. 3i Atlas, like Oumuamua before it, reminded the world that investigation does not always bring clarity. Sometimes it deepens the unknown. Sometimes it multiplies possibilities rather than narrowing them. The paradox is unsettling but also profound. The universe may not be designed to be understood by the minds that contemplate it. Perhaps that is the true lesson of these visitors. Not simply that the galaxy is alive with fragments of shattered systems, but that human comprehension will always move within the shadow of mystery. Each object becomes a mirror, reflecting back the ambition of a species reaching beyond its grasp, and the humility of confronting a cosmos that is vast beyond measure. In the end, Three-Eye Atlas faded just as the others did. Its brightness dimmed, its path curved away, and it slipped once more into the infinite dark. No answers were secured, only echoes of questions that remain. The fragment becomes invisible again, but its presence endures in memory, in data, in the haunting awareness it left behind. The image is simple yet enduring, a body from another star crossing the threshold of our skies, lingering briefly, then vanishing. It is a reminder that the universe speaks most often not in declarations but in silence. And in that silence lies both the riddle and the wonder of existence itself.